In 1965, a NASA engineer discovered a rare geometric pattern forming in the outer solar system. Jupiter, Saturn, Uranus, and Neptune were drifting into a specific arc, an alignment that occurs only once every 175 years. This alignment created a unique opportunity for a gravity assist. By flying close to a massive planet, a spacecraft can use that planet's gravity to bend its path and gain significant acceleration, slingshotting towards the next destination using almost no fuel. NASA's plan was to use this window to explore the furthest reaches of our solar system, while simultaneously carrying a message from Earth to any intelligence that might find it. The engineers faced a massive technical hurdle. The probes would be too far from the sun to use solar power, and they would have to operate using a computer with only 69 kilobytes of memory, less than the size of a single digital photo today. Voyager was an engineering puzzle as much as a journey of exploration, requiring scientists to reach the outer planets using hardware from a pre-digital era. To solve the power problem, NASA equipped the probes with radioisotope thermoelectric generators. These aren't batteries, they are small nuclear power plants. These devices convert the heat released by the radioactive decay of plutonium directly into electricity. This allows the probes to survive the freezing darkness beyond Mars, where solar energy is no longer viable. The gravity assists worked. Voyager 1 gained enough momentum to leave the ecliptic plane, the flat path where planets orbit, reaching a speed of over 60,000 kilometers per hour. As Voyager 1 approached Jupiter, it began transmitting data that changed our understanding of the planet, including clear, close-up images of its atmospheric bands and the Great Red Spot. When it passed the moon Io, the probe captured evidence of active volcanoes, the first time humans had ever seen volcanic activity on another world. Meanwhile, Voyager 2 took a different path, becoming the first and only man-made object to fly by the ice giants, Uranus and Neptune. These discoveries rewrote our maps of the outer solar system, proving that the constraints of 1970s hardware didn't limit the mission's reach. But the mission didn't just end at the planets. The ultimate goal was to reach the edge of the solar system, which raised a difficult question. How do you prove you've actually reached interstellar space? In August 2012, Voyager 1's plasma instruments recorded a sudden, sharp spike in electron density. The solar wind had dropped away, and the probe was now being hit by the wind of interstellar space. Now that the probe was in the void, its second mission became its most important. But engineers still had to figure out how to send a detailed message to an alien race using a computer that couldn't store a single JPEG. Previous messages, like those on the Pioneer probes, were limited to basic metal plaques with simple line drawings of humans and our position in the galaxy. For Voyager, NASA created the Golden Records, 12-inch gold-plated copper phonograph records carrying 55 languages, music from across the globe, and 115 images of Earth. To get around the memory limit, engineers projected photos onto a screen and recorded them with a camera, converting the video signals into audio waveforms. The images are physically stored as sound in the grooves of the disc. To talk to the universe, we had to encode our visual world into sound, trusting that another intelligence could look at our diagrams and reverse the process. Voyager 1 is now approximately 24.7 billion kilometers from Earth, the farthest any human-made object has ever traveled. Maintaining that distance required sacrifices. In 1990, after taking one final portrait of the planets, NASA permanently shut down Voyager's cameras to save every possible drop of power. That power is almost gone. By 2025, the decaying plutonium will likely fail to produce enough heat to run the electronics, and we will lose contact with the probe forever. Even after all the electronics die and the probe goes dark, the Golden Record will continue to drift. It is designed to survive in the vacuum of space for billions of years. The technology of the 1970s will eventually fail, but Voyager remains a time capsule, a mathematically precise record of humanity that will likely outlive the civilization that created it.